Today we're going to look at the reduction formula in trigonometry. Before we start, we need to make sure that the calculator is on the correct setting. So turn your calculator on and type sine 30 equals. Your answer should be a half. If it is not a half, you will need to do the following. Press Shift, then Mode, and choose option 3, degrees. And this will change all your calculations to degrees. And you're now ready to go. So you should try sine 30 again, and hopefully you get a half. Below is a table of calculations that I'd like you to do. I'd like you to write down the table and then answer all questions, correct to 3 decimal places where necessary. You should pause the video at this point and complete the table. You've had time to work on these calculations, and these are the answers you should get. Now I want to look at these answers in a few different ways. The first way, I want to look at each row. In the first row, I notice my angles are 30 degrees, 40 degrees, and 45 degrees. And they are all angles that appear in quadrant 1. In other words, between 0 and 90 degrees. The second row, 150 degrees, 140 degrees, and 135 degrees, are all in quadrant 2. In other words, between 90 and 180 degrees. The third row, 210, 220, and 225, all lie in the third quadrant, between 180 and 270. And the fourth row, 330, 320, and 315, all lie in quadrant 4, between 270 and 360. Now what we realize is in quadrant 1, all of the answers are positive. In quadrant 2, only sine is a positive number. In quadrant 3, only tan gives me a positive answer, and in quadrant 4, only cos gives me a positive answer. And why is that? That is because of the cast diagram, which we learnt in the last lesson. Remember, all angles are positive in the all trig functions are positive in the first, sine is positive in the second, tan is positive in the third, and cos is positive in the fourth. I now want to look at them in a slightly different way. I want to look at each column. All right. And what I notice is all the answers in the first column are 0, 5. Some are positive and some are negative. Now the first two are positive, and that is because sine is positive in the first and the second quadrant. And the last two are negative because sine is negative in the third and the fourth quadrant. Now the same applies to the second column. They're all the same, but sometimes I get a positive answer, sometimes I get a negative answer. And in the third column, again, I get all answers of 1, but sometimes positive, sometimes negative. Now, why do I get the same answer in each column? There's a reason for it, and let's look at that reason. If I just look at the 30 degrees, 30 degrees is an angle in the first quadrant. If I measure an angle of 150 degrees, it will be around in the second quadrant, but interestingly enough is that it's only 30 degrees away from the x-axis. If I measure an angle of 210 degrees, I'm going to go all the way around to 180, but a little bit further to get an angle of 210. But how much further? 30 degrees. And then 330 degrees, I'm going to go nearly all the way around, but I'm going to stop 30 degrees short of a full circle. So all those angles are exactly 30 degrees away from the x-axis. If I look at the second column, all of those angles are exactly 40 degrees away from the x-axis. And in the last column, they're all 45 degrees away from the x-axis. If I want to calculate 150 degrees, I can go 180 degrees minus 30. 210 degrees will be 180 plus 30, and 330 degrees will be 360 minus 30. So 30 is coming up in each of those equations. So it's this middle part in the green block that I want to have a look at, because those are going to give me my rules that I'm now going to add to my cast diagram. Here's my cast diagram that we learned about last time. We now want to add our rules. In the first quadrant, theta will always lie in the first quadrant. Now there is an angle in the second quadrant that will give me exactly the same answer as, for example, sine theta. And that angle will be 180 degrees minus whatever theta is. In the third quadrant, my rule will be 180 plus theta. And in my fourth quadrant, my rule will be 360 minus theta. So you should add your rules to your cast diagram. Let's see how we need to use these in questions. We need to write the following as a function of theta only. In other words, I just wanted to say tan theta, for example. The problem is I just need to figure out, will I get a positive answer or a negative answer? So we need our cast diagram. Now 360 degrees minus theta lies in the fourth quadrant, and in that quadrant tan should give me a negative answer. So I can get rid of 360 degrees as long as I write a minus in front of my function. For the second example, again we're looking at 360 minus theta, but this time we want cos of 360 minus theta. 360 minus theta lies again in the fourth quadrant, but in this quadrant cos is positive. So we can get rid of 360 as long as we keep cos positive. And in the third quadrant, in question 3, we've got cos 180 minus theta. 180 minus theta is up in quadrant 2, where cos is negative. So my answer will be negative cos theta. Here are 3 more for you to try on your own. Pause the video now. If we look at the cast diagram, at 180 degrees minus theta, that is in the second quadrant where tan is negative. Question 5, 360 degrees minus theta is in the fourth quadrant where sine is negative. 360 degrees plus theta is one we haven't looked at before, but let's think about it. Theta lies in quadrant 1, and if I add 360 degrees, I'm getting back to the same place. I'm going in a full circle. So I end up back in the first quadrant where cos is positive. So I don't have to write 360 degrees anymore. I can just write cos theta. Now in a test or exam, we will give you 1 or 2 of these questions, but we'll put quite a few trig functions in one question. Before we try this question, we've got to remind ourselves of the identities that we learnt about last year. There were 2. The first identity is that sine squared theta plus cos squared theta is always equal to 1, which means if you get sine squared theta plus cos squared theta in your final answer, we expect you to go one step further and write down that you know that is equal to 1. And the second identity is that tan theta is equal to sine theta over cos theta. In other words, if you've got tan theta, you can expand it to sine theta over cos theta, or the other way around. If you end up with sine theta over cos theta in your final answer, we expect you to simplify further and write tan theta. Let's look at this question out of 6 marks. We need our cast diagram to solve it. Let's start with sine 180 minus theta. 180 minus theta lies in quadrant 2. In quadrant 2, sine theta is positive. Cos 180 plus theta lies in quadrant 3. Now in quadrant 3, cos is negative, so I write negative cos theta. Please notice that I put my trig functions in brackets. I don't want to suddenly make that subtraction, sine theta minus cos theta. It is sine theta times minus cos theta. So just to avoid mistakes, write your trig functions in brackets. Tan 180 plus theta. Now at 180 plus theta, that lies in the third quadrant, and in the third quadrant, tan is positive. 360 minus theta is in the fourth quadrant, and in that quadrant, cos is positive. All right, what can we simplify? Well, we can cancel cos theta with cos theta, but we've got that minus. We mustn't forget about it. So I sometimes just put a little circle around it so that I don't forget about it. And how can we simplify further? Well, we can't do anything with sine theta. That just comes down. That minus, I don't want to forget about it, so I'm going to bring it down and just write minus 1 because the cos thetas are cancelled. Tan theta, can we simplify further? Well, we've got our identity that we can use. So tan theta, I can rewrite as sine theta over cos theta. Let's take it one step further. In my numerator, I'm going to have sine theta times minus 1, which gives me minus sine theta. Now I am dividing by a fraction, so instead of dividing by a fraction, we can tip and times. So I end up going times cos theta over sine theta, tip and times. How can we simplify further? Sine theta can cancel with sine theta. And my final answer is minus cos theta. You should now take the time to do the worksheet on the reduction formula.
Thanks for watching Max Maths. If you liked what you saw, please like, share and subscribe.